Hello everyone. Okay, this video I just give the final part of the 1D elastic collision. Let us did a little check. Hmm. Check what? Let's check the velocity of center of mass before and after collision. Mm-hmm. Yeah, it's just very quick check. So this video will not be so long. Okay. Mm-hmm. So we want to check is what's the 1D collision here. But left center of mass velocity before collision, after collision. Okay, let us check. Do they the same? I think you know the result. They must be the same, but let's still do the little check. Okay. Okay, so before collision, what's the velocity of center of mass? Before collision. Okay, what's how to calculate center of mass, the velocity of center of mass? Do you remember that? You remember I write it for you. COM is equal to that's that. Now just don't use vector. Okay, let's keep vector. Okay, okay, capital M summation alpha M alpha V alpha. Okay, so right now our center of mass before the collision is equal to well to object M1 M2. So total mass is M1 plus M2. And that's dimension m1 times velocity, m the mass of each particle times its own velocity, and then all together. Okay, so it's m1 v1 plus m2 v2. Okay, that's the velocity of center of mass before the collision. Okay, so what's the after collision? Okay, after collision. Okay, yeah, same formula, but the B1, but we have a B1 prime and B2 prime. Okay, so let's say VCOM with prime because after collision we use prime. So this will be M1 plus M2, M1 V1 prime plus M2 V2 prime. Okay, so and right now we have put the formula in there. What's the formula? Let me copy the formula. I think we need to copy the formula because, like I say, this formula is very hard to remember. Let's see, can we copy this? Okay, copy. Uh, And let's copy here. Paste. Okay, and the other one. Yeah, yeah, it's very hard. Okay. Uh, it's very hard to circle this. Okay. I, 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 pass. And that's. Can I move? Oh no, I cannot move this. I still don't know how to move this. Sorry. I still don't know how to move this. Very. It's auto. Okay. 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 And then we clean up something. Okay. Okay. Just take a little time to move copy this equation. So V2 prime equal to. Okay. So right now we have to substitute this two into the equation, right? So I substitute this one and substitute to this one. Yeah. Yeah, it's a kind of a little yeah, kind of a very lots of algebra work. Okay, so but it's not too difficult. but it's not too difficult. There are lots of terms, but that doesn't mean it's very difficult. It's not that difficult at all. So it's m1 plus m2, m1 minus m2, v1, yeah, v1 plus m21 plus m2, 2m2 and v2, right? Yes, v1. It's v1. And this is the second term, v2 price m1 plus m2, 2m1 v1 plus m1 plus m2, m2 minus m1 v2. Oh, okay. Hmm. Yeah, that's yes. It looks there are lots of terms. Let me check. Did I really write something wrong here? Hmm. Ah, okay. Ah, is this correct? Hmm. No, this is correct. Hmm. I think this is correct. Okay, but lots of terms here. Hmm. Okay. Okay. So let's figure this out. Okay, so looks like m1 plus m2 we have a square here. Okay, and then let's see. It's not that difficult. Okay, let's see. Okay, so we times m1 into layer, so it's m1 square minus m1 m2 v1 plus 2 m1 m2 v2. Okay, this is the first term, and the second term is, oh, sorry, the second term is, yeah, m1 plus m2 square can be factor, can be moved out, so, and it will become 2m1 m2 v1 plus m2 square minus m1 m2 v2. I forgot a v2 here. Yeah, I think I also missed a term over there. Okay, it's m2 square. Okay, m2. Oh, okay, m2 square v2 minus m1 m2 v2. Yeah, I missed a term here. I think you found it. m1 square v1. Okay, m1 square v1. So let's see if there's any combination here. Is there any combination? Is there any combination? Okay, looks like not. Okay, 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 it's one. Okay, let's see. Okay, so m1 square v1. So let's see. Okay, so okay, this term can be associated with this term is associated with this, and let's see. Oh, and this term is associated with this term. Okay, so I hope you can find out. Okay, I hope we can find out very quickly. Okay, so it's m1 square v1 plus m2 square v2. And this 2, okay, this 2 minus is equal to m1, m2, v1. This is the m1, m2, v2 plus m1, m2, v2. Oh, this m1, m2, v2. Okay, I think we're almost done. Okay, everything is done. Okay, so we can get an answer very soon. Okay, so let's see. I think I can group these two terms together and also what's it called? Group these two terms together. So what I'm talking about is, so here is the same m1 plus m2 square And when Google this two purple term, what we have, Google this purple term, we have M1V1 times M1 plus M2. Okay. And when Google this the orange, this two orange term, okay, we can put the M2V2 out. So this will be M2 plus M, actually it's M1 plus M2. Okay. And finally, we can factor this out. Okay, this is cancel. This will be cancelled and cancel this. So what the conclusion is M1 plus M2 is M1V1 plus M2V2. Okay, so that means this is, don't forget, this is our VCOM prime. Okay, and it's equal to the center of mass, velocity center of mass before the collision. Okay, it's very true because the system is isolated. There is no external force in the system. Yeah, the collision is some. There's a collision is internal forces. Okay, that's right. The conclusion. Collision, internal forces. Collision force is the internal force. Internal force and system and isolated system. An isolated system. There is no external force in this system. Collision is internal force. So of course, the center of mass should be the same before the collision and after the collision. Okay, because yeah, it's isolated system and collision is just the internal forces. And yeah, that's just the let's repeat the Newton's second law of motion one more time. Okay, it's just a quick check. Okay, the center of mass before collision and after collision is the same. Okay. Okay, so it's a very quick check, and yeah, that's some algebra work, but that's not really too hard, I think. Okay, okay, just show you the center of mass velocity before and after collision is the same because system isolated. Okay, and collision force, internal force. Okay, see you in the next video. Bye bye. Hmm, nah.